Hello, welcome to my channel. We have been solving this past paper. So right now I have this paper 1, pure math 1, October number 2024. So we have solved 10 questions out of in this paper. So let me go to the question number 11. This is the last question of this exam. Okay, so question number 11 is right here. Okay, so what is it? The function f is defined by this expression where x is a real number. Express f of x in this form. Okay, this sounds easy. So f of x is given as 3 plus 6x minus 2x squared. Basically, to complete the square. So let me write it in this way at minus 2 and then x squared. And from here, I will have minus 3x and plus 3 is derivative. So make sure that these two expressions are same. If I open this bracket, it will become minus 2x squared, this is this one, and then minus minus plus 6x, which is this one, and plus 3, which is this one. So it's the same thing. Okay, now let me complete the square. So 3, I'm writing this 3 first, and then minus 2, and then I have x squared minus this 3x, I must write it as 2 times x. Now what should I write here so that it becomes minus 3x? I should write 3 by 2, right? The 2 will cancel the 2 and it will become minus 3x. Now it shows me that the b is 3 by 2, so I have to add 3 by 2 square to complete the square. But this is an extra thing, I have to get rid of it. So I will do minus 9 by 4. Okay, so this expression is same as this one. Right? I don't know. 3 is here, minus 2 is here, and these are the only two terms. These two cancel, and I have this term only. Okay. Okay, so this is 3 minus 2 into, from here to here, it is x minus 3 by 2 whole square. Okay, a minus b square is a square minus 2a into b plus b square. And minus 9 by 4. I hope you're following me every step. 3, this will become minus 2 times x minus 3 by 2 is basically 1.5. I can write it that way. Okay, and then minus minus plus, and it will become 2 multiplied by this one, it will become 9 by 2, right? And 9 by 2 is half of 9 is 4.5. So 4.5 plus 3 is going to be 7.5 minus 2x minus 1.5 whole square. So now this is in this form, a minus b and x minus c whole square. Okay, so this is what we have to do in part A. So we are done. Okay, now what's part B? The graph of this function is transformed to the graph of this function by a reflection in one of the axes followed by a translation that is given that the graph of. Okay, first of all, let me try to sketch this graph quickly. How will we sketch it? If I have y is equal to x squared, it is simply this thing, right? Okay, if it is minus x squared, it would be something like this. If it is minus 2x squared and x minus 1.5 squared. So 2 will just make it squeeze a little bit, but 1.5 will shift it to the right. So at this point, I have this graph, something like this, right? And then when I add 7.5 into it, minus 2 into x minus 1.5 squared, it will push the graph up over here. So now, hold on a second. Okay. Yes, do it again. So it is something like this. I'm not very good at the drawing. So this point is 1.5. This point is 7.5. And you can see when x is 0, the value of y was 3. You see from here, when x is 0, value of y would be 3 only. So it means that this point must be 3. I'm not very good at drawing. Anyway, okay, so this is the graph of the given function. But now, so this is f of x, right? Okay, now they're saying that the graph of this y is equal to f of x is transformed to the graph y is equal to h of x by a reflection in one of the axes followed by a translation. Okay, it is given that the graph of this has a minimum point at the origin. So when you reflect it in x-axis, this point will come over here and it will go something like this. So this point is going to be 1.5 and here it is minus 7.5, right? So this is the reflection only. And then it is said it is translated and said that the minimum point is at the origin. So we have to shift this point to the origin, right? So when I shift it, it will be something like this, right? Okay. And the translation is minus 1.5 and plus 7.5. I have to go 1.5 left and 7.5 up. Okay, so I hope I answered the question. The graph of this is transformed to the graph of this by a reflection in one of the axes. So the reflection is an x-axis, right? Followed by a translation. So translation is this much. So this is the translation. And reflection is in the x-axis. Okay, I hope you understand this whole question. Now part C, the function g is defined by this equation. Okay, so this, remember we sketched it and it came out to be yes, something like this. So this point is 1.5 and 7.5 and this point is 3. So the y-intercept is 3. You can check that this intercept comes out to be minus 0.29. Okay, it's not important, but I'm just showing you that this x-intercept is this one. Okay, but now if this graph is for x less than 0, so it means we're not talking about this part of the graph. Okay, so only this is what we're interested in. Let me show you with the different color that the graph we're talking about is this only. Okay, so this is my g of x. So the graph of g of x and explain why g is a one-to-one function. Okay, you're not able to find the coordinates of any in a second. Okay, you see here for any x value give you only single y value, right? Or any y value has only one x value. That's why it's a one-to-one function. The original function, it is not because for any given value of y, there are more than one value. So there are two different values of x which are giving you the same value of y. But if you put this restriction, then uh, uh, any value of x or any value of y will give you a single value of x only, right? Or any value of y corresponds to only single value of x. So that's why this is a one-to-one function. Okay, what is next part of it is for C and this is D. Okay, and I think this is the last part here. Okay, state the graph of inverse function. Okay, remember inverse function, how do we plot inverse function? Okay, my graph, original graph is something like this, right? This point is 3. Okay, I had to find its reflection in this line, which is x equal to y. This line is x equal to y. So when I reflect this this sketch in this line, this point will come over here, and it will be something like this. Okay, so this is my G inverse function. Okay, only in C and find an expression for G inverse. Okay, very good. You see, G of x, it was given by y is equal to G of x, and G of x was, yes, this thing. Let me write it here. Y is equal to 3 plus 6x minus 2x squared, right? So this was my original G of. You know, how do we find okay, and you know that we transform into this one. It was 7.5 minus 2 times x minus 1.5 and squared, right? So this is my G of x. If I want to find the inverse function, what do? We replace x and y. So x equals 7.5 minus 2 into y minus 1.5 and squared. And now I try to solve the equation for y. Okay, so if I bring this whole thing, it is 2 times y minus 1.5 square equals 7.5 minus 1. Okay, if I take q on the other side, it will give me 7.5 minus x over 2. And then this is equal to the square y minus 5 square. If I take the square root on both sides, so y minus 1.5 is going to be 7.5 minus x over 2. Okay. Plus minus. Let me write it plus on both sides now, and then I will explain how I will take. And y is equal to 1.5 plus minus under the root 7.5 minus x over 2. Right? Okay. But you see over here, for any, this inverse function I'm talking about, for any value of x, the value of y is negative. Right? So it shows that we have to select the negative value. So my function G inverse x is basically 1.5 minus 7.5 minus x over 2. Okay, so this is our inverse function. Let's confirm when x is 3. So you hear this point is 3, so this has to be 3. So if I substitute x equal to 3, the y or the inverse is comes out to be 0, because 7.5 minus 3 is 4.5. 4.5 half is 2.25. 2.25 square root is 1.5. So 1.5 minus 1.5 is going to be 0. So yes, it is this point. So anyway, this is our inverse function, and that's it. Okay, I hope you understand every part of this problem. And if you ever have any question, you can always ask me in the comment section. If you like this video, if you find them useful, then please subscribe my channel. Thank you very much for watching. See you in the next video.